Heat. It's what brought me out here today. I got some sunlight. I've got a t-shirt on because it's balmy, like 57 degrees out. It's sunny. It's really nice. But what is that heat really? And why is it such a problem? I mean, climate change is supposed to be an issue with temperature, and heat is a measure of temperature. Wait, temperature is a measure of heat? I don't get it. What's it all about? Well, it's about infrared. And infrared seems to be a lot of the problem. Infrared is what we feel when we feel heat. Infrared radiation. And the light coming from the sun up there, well, it's visible light mostly, but I can feel the infrared. I like it. My skin absorbs it, and some UV, unfortunately. My shirt absorbs it, the land absorbs it, and I can feel it. It feels warm. That's infrared. And the heat that you're using in here, it's infrared too. Not the light. I mean, that's just a light bulb, that's visible. But the heat, what I can feel, infrared. Infrared. And that infrared gets trapped in our atmosphere, and that's what keeps us alive. The temperature does, at least. If we didn't have any infrared, we wouldn't have any temperature. And if we didn't have any temperature, we'd be cold. So what's that have to do with climate? Well, if the climate's changing, the temperature has a lot to do with that. If the Earth is warming up in some places, warmer than it should be, and if it's colder in other places, colder than the regular averages, that creates a series of problems. Well, what's that have to do with infrared? Well, the amount of infrared that the Earth has at any one time is balanced. It comes in while the sunlight brings it in, the Earth absorbs it, and it just bounces all around the place. Some of it gets reflected right off the clouds, and because they're bright white, it's their albedo, but albedo will come later in a different conversation. And that infrared is what helps sustain life. Now, infrared is trapped by our atmosphere, the lower part of it, especially the troposphere that we live in, and it gets trapped by the gases that are in the atmosphere. So the gases that are in there most abundant is nitrogen and oxygen. Handy for us humans because we need oxygen to survive. But there's trace gases, and one of those trace gases is carbon dioxide. And carbon dioxide has this amazing and wonderful ability to absorb infrared radiation. And if it can absorb it, it can store it, it can trap it, and it can keep it close to the ground. And if you trap infrared, you get kind of warm. Anybody that's ever worn a black sweatshirt on a sunny day knows it will get warm. Black t-shirt, black top walking in bare feet, black car, black leather car seats. Ow, really? And carbon dioxide levels on Earth are increasing. There's no denying it. Scientists have been measuring it since, I guess, the early 1950s. It goes up in a cycle, it goes back down in a cycle. I mean, these plants around me, as they grow, are going to absorb some of it. A high percentage of the plants on the planet are in the northern hemisphere, and the northern hemisphere has a lot of the civilization that's causing all the extra carbon dioxide. It sort of balances a little bit. When the plants grow, they absorb the carbon dioxide. When they go dormant, a lot like they are now, they don't absorb it. Well, they don't absorb as much of it. And because of that, the level goes up when it gets cold outside in the wintertime, and it comes back down in the summer. Unfortunately, it doesn't come all the way down, and that leads to a pattern. That leads to a trend, an upward trend, that's kind of alarming. Now, if you've ever been inside of a greenhouse, it's pretty warm in there pretty much all the time. You know, that's because the light can get in through the glass, but once it gets absorbed, re-radiated as infrared, that's what we can feel, it can't get back through the glass. It sort of bounces off. If it bounces off the glass while it's already stuck inside, well, if you think about it, it'll just increase and increase and increase and increase. So that's why they call it a greenhouse gas. It kind of acts like a greenhouse by trapping that infrared. But haven't we had ice ages in the past? Like 6 of them? And ice ages are cold. If it cools off enough, the Earth will freeze and then it'll warm back up again. If it warms back up again 1 million years ago, doesn't that mean that this is totally natural? Well, sure, it could mean that. But if you look at the carbon dioxide levels, which are the tricky ones, they have been going up and keep going up and up and up and up and up and up. So we might have a natural cycle, but we have a piece that humans are making worse. So what does that really mean? I guess it means that we have to pay attention to carbon dioxide levels while still assuming, at least on some level, that there might be a natural component to it. But what if there's not? And isn't carbon dioxide good for plants? Wouldn't it be a great idea to just have more and more and more of it? Because more carbon dioxide, more plants, less carbon dioxide, sort of. So instead of focusing on what we know is happening and the dynamic between the interacting variables, instead of focusing on that and arguing about whether or not these levels are normal and whether or not these levels are natural and so on and so on and so on, I would argue, by the way, that humans are exaggerating the effect, is we look at what the potential issues can be. And for those of us that live in Delaware, lowland areas near the coast, that's water. The ocean rises, that's a problem for those of us that live near sea level. We live in the mountains, we're a couple of miles above sea level. Denver, for example, the mile-high city, sea levels would have to rise incredibly to affect them. But places like Delaware, Chesapeake, where we are, we worry about those problems. And because we worry about the problems, we start trying to figure out, I guess, solutions. So here's the evidence. In the geologic record, we have these cold periods called ice ages. There they are. That's the evidence. So that has to mean that the Earth warms up and cools off on its own naturally for some reason. That's half of the argument. It's been doing that, well, at least as far back as we know. But here's the other side of the argument. Take a look at this curve. This one is carbon dioxide. You can see that cycle I was talking about. Winter, summer, winter, summer. In the winter, carbon dioxide goes up. In the summer, it goes back down because the plants are absorbing it. But it doesn't go all the way down, and then you get this curve. And that curve is the problem. If you look at the carbon dioxide record, you get this cycle, 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 spike. That's humans. That's not part of the cycle. If that's not part of the cycle, Houston, I think we may have a problem.